So we right here have the 2024 USAMO Problem 1. And to solve this problem, let's first take a look at the problem statement, right? So it's asking us, or it's telling us that for all integers n, which are greater than or equal to 3, we have the following property that holds. So if we list out all the divisors of n factorial in increasing order, as in this form, so say from D1 and then D2 all the way to dk is equal to where the say d of 1, which is the smallest divisor, is of course 1, and the largest divisor is of course n factorial, then we have that d2 minus d1 is smaller than or equal to d3 minus d2, smaller than or equal to all the way to dk minus 1. So we want to find, remember, all integers n smaller than or equal to 3 such that this holds. In other words, the gap between the divisors continues to get bigger, or let's say it doesn't decrease. Okay, so how do we solve this problem? Okay, so we are going to, let's say, have this, let's say, theory that only n is equal to 3 and n is equal to 4 work. So in order to prove that this is true, right, we need to prove that, well, first of all, clearly n is equal to 3 and n equals 4, they are valid values. However, we also need to prove that, first off, n must be smaller than 5. So if n is, let's assume it's greater than or equal to 5, right? Then let's let x be the smallest value such that x plus 1 does not divide into n factorial. Therefore, we also are going to set x plus k be equal to the smallest factor that's above x, right? That does divide into n factorial. Now you then note that if you consider n factorial divided by x minus 1, n factorial divided by x, and n factorial divided by x plus k, then we can note that, well, this equality must hold true. And therefore, we know that n factorial divided by x minus 1, because of the problem hypothesis, minus n factorial divided by x is greater than or equal to n factorial minus x minus n factorial divided by x plus k. Now, clearly, it's possible to observe, right, that this equality does not hold for any n greater than or equal to 5. Furthermore, it's not equal for, or it's not possible if k is, let's say, greater than 1, right? So, in that situation, then we can conclude the next, observation, right? Now, a key thing to note here, something that's critical, is that this equality is really equivalent to us saying that, well, 1 over x divided by 1 divided by x times x minus 1 is being greater than or equal to k divided by x times x plus k. Equivalently, it's also equal to just stating that x plus k is greater than or equal to k times x minus k. Or, in other words, that x divided by k minus 2 is smaller than or equal to k, smaller than or equal to 2, which means that x must be smaller than or equal to 4. Right, now this is a contradiction because you know that then x is, well, in the range of 1 to 5. Therefore, n, by contradiction, once again, must be greater than, or can never be greater than or equal to 5. And so then what we can simply do is just check all n values from 1 up to 4. And when we do that, we find that 3 and 4 are our only possible solutions.